In this video, I will explain you method of changing magnetic flux linked with a coil. So in previous lectures, we have learned that for an induced EMF, we need change in magnetic flux. This is the equation. Now to get an EMF induced, the only way is changing the magnetic flux. Now we know the equation for magnetic flux that has B A cos theta. These three elements. These are the three parameters that makes the equation. Now one way is changing magnetic field intensity. We will see that how it can be made. I have a coil now connected with the galvanometer. See, it is the experiment so far we have learned. When I am bringing the magnet from here to here, see, out of these three elements, which one is changing? Is area of cross section of this coil, is it changing? No, area is not changing. Is cos theta is changing? No, because area, the direction of area is this, and that is perpendicular, that is parallel, always parallel to the magnetic field. Both are in the same line. So area doesn't change and angle also not changing. What is changing here? Magnetic field intensity is changing. Here, see, when the magnet was here, it was weaker magnetic intensity linked with this coil. But here, see, more number of field lines are linked. So this is an example for change in magnetic field intensity that created a change in flux. Next is change in area. How is that possible? With this coil, I can say that rotating may change the area. So better example will be, let's say I have a magnetic field intensity here into the plane and B is not changing with respect to the time. And I kept a coil here in this way. So this is a conductor in the shape of C. Okay. Now I am going to close this with a rod. So this one is a conductor in the shape of C, letter C, okay. And I have connected a rod here. Now this makes a closed circuit. Okay. Now the area is length into breadth. Now if I am gradually keeping it, gradually or immediately doesn't make any difference. So if I am keeping my rod here, now the new closed circuit will be this. And what is the change? Now this area is lesser than the previous area. Now the area that is linked with this closed circuit decreases. Basically current will only go through a closed circuit, right? So you only have to consider the closed part. So this was the closed part previously, but now this has become a closed circuit. So what is the change? Change in area. So this is an example for change in area. Now next case is change in theta. Change in theta. How is that possible? Now I have magnetic field in this direction. What is theta? Angle in between area vector and magnetic field. Now this is my area. Now area vector and magnetic field are in line or the angle is 0. Now when I am rotating the coil in this way, area changed, area changed, area changed, area keeps on changing, and this will create an induced EMF across the circuit. Let's say this margin or this border is representing a closed circuit, okay, in this way. So the area, the angle area makes with magnetic field intensity or magnetic field lines keep on changing, and that will create an induced EMF. And this is basically the working of AC generator, okay, where we will be keeping a coil and this coil will kept on rotating. So to rotate this coil, we will use either dynamo or water. So water, when it is coming from nozzle and exerting a pressure on the blade, this will keep on rotating and that will be in a constant magnetic field. The theta keep on changing and that will induce an EMF and a current in it. Anyway, we will go into this deeper in AC and even at the end of this chapter. Okay, so these are the three parameters when changed that will make a change in magnetic flux. This is very, very important and we will see all of this in the lecture. Okay, thank you.